Number 9, researchers want to evaluate the effect of a natural product on reducing blood pressure. They plan to carry out a randomized experiment to compare the mean reduction in blood pressure in a treatment group and a placebo group. They will use the data to perform a test of HO equals mu t minus mu p equals 0 versus HA equals mu t minus mu p is greater than 0, where mu t is the true mean blood reduction in blood or mean reduction in blood pressure when taking the natural product, and mu p is the true mean reduction in blood pressure when taking the placebo. So natural for T, treatment, and placebo for P. And the researchers would like to detect whether the natural product reduces blood pressure by at least 7 points more on average than the placebo. Okay, if groups of size 50 are used in the experiment, a two-sample t-test using alpha equals 0.01 will have a power of 80% to detect a 7-point difference in mean blood pressure reduction. If the researchers want to be able to detect a 5-point difference instead of a 7-point difference, what's going to happen to the power? And you have some options. Is it going to be greater than 80%? Is it going to increase? Is it going to be less than 80%? Is it going to vary depending on the means? Would it still be 80% or would it be less than or greater than 80%? And let's do a little visual here. All right, I have a little power simulator hooked up here so we can see. Power is really a hard thing to kind of grasp. So I have some parameters set. And the idea is that what happens if I want the true mean to be instead of 7 points off, 5 points off. So if I do that, notice that the power went down. Okay, let me show you that again real quick. I'm at 7, and if I take that power, if I take that difference and make it smaller, then certainly there's going to be less power to the test. So the quick way to explain that is um, if the actual alternative, I'll write this down. If the actual alternative, actually the actual mean, excuse me, um, is closer to the null, the test will have less power. You don't need to know how to calculate it. You just need to know that when it's a more powerful test, when the actual alternative is more in the extreme direction, where the actual mean is more in the extreme direction, um, in the direction of the alternative than the null. Okay. Also, it's a more powerful test if you up the significance level because you're more likely to reject the null hypothesis as well. So let's see, what is it? It's going to be less than 80%. That's a tricky question, but again, if it's closer to the null, it's going to be a reduced power.